Hello there, this is Haddad here again. So let's talk a little bit about neighborship on OSPF and how it is formed and what are the conditions needed for two connected routers to be able to form neighborships inside the OSPF. What I have here, I have router 1 and router 2. They are both connected on Ethernet 1 interfaces. And they have an IP address from the range of 192.168.12.1 on router 1 and .2 on router 2. And both of the routers are inside the OSPF area 0, which is the backbone area. We have seen in the previous lecture when we enable OSPF on router 1 and on router 2, and in case they have IP connectivity, then directly they can form neighborship. Okay, this is good, but there is some process happening in the background for this neighborship to happen, and there are some conditions needed to be met so router 1 can be enabled to router 2 and vice versa. And these conditions are listed over here. You can see here I have taken a picture about the OSPF header and the hello data inside OSPF. Say that we enabled OSPF on router 1. Router 1 directly will send a hello packet to router 2 on the address, multicast address 224.0.0.5. Okay, and then he will wait for router 2 to answer him back. If he doesn't answer back, then in this case there is no neighborship formed, and there is a reason why he doesn't answer back. Okay, same on router 2. When he enables OSPF, then also he has to send hello packet to the router also 224.0.0.5. Okay, so let's look a little bit about the conditions that the two routers need to meet in order to be able to form the neighborship. I have highlighted them here. First of all, they need to be in the same area ID. Okay, let me just clean here a little bit. So router 1 is on area 0 and the router 2 is also on area 0, the backbone area. Then in this case, the area ID is met. The second condition, they need to have the same authentication. In our previous lab, we didn't talk about authentication because we're going to do authentication in the upcoming lectures. But for now, what is authentication? Say that you don't have over here a link between router 1 and router 2. Instead, you have a switch here. You have a switch, and router 1 is connected to the switch. Router 2 is connected to the switch. You have OSPF here, and you have OSPF here. Then, in this case, they have neighborship. But then, if someone like an intruder who can reach our switch and he can put a router over here, or he can emulate OSPF on his PC using some softwares. Okay, and he has also OSPF. If we don't have authentication, he may be able to get all those hello packets, and possibly he can form neighborship, and also he can enter to our network and he can receive all our routes. That's something we need to avoid. Okay. For this reason, what we can do, or what OSPF can allow us to do, is to make authentication, and which is like a password for any routers to be able to be inside the OSPF process. They need to have the same password, the same authentication, and they need to pass this authentication, and in this case they can enter inside the OSPF process. And this is very important to remember. So in our case, we don't have that. So I'm going to make a check for the authentication. We already have checked the area ID. Then the second thing that it's important to form the neighborship between two connected routers is to be on the same network. Okay. In our case, we do have that because it's 192.168.12.1, 192.168.12.2. Then that means the two routers are on the same network. Actually, the two interfaces, or the two connected interfaces from each router should be on the same network. Okay, so this is met over here. Then the other condition is to have the hello interval and the dead interval identical. On OSPF using MikroTik routers, I just said to you that they will send hello packet every couple of seconds. The hello interval on MikroTik, the hello interval, it's 10 seconds. So every 10 seconds, the MikroTik router will send to his neighbor a hello. Okay, and router 2 needs to answer back. Then in this case, router 1 knows that there is the neighbor is still valid. The default is 10 seconds. The dead interval is 40 seconds. That means in case router 1 will send a hello packet to router 2 and he doesn't hear from router 2 for 40 seconds, 4 times more than the hello interval, and then in this case he believes that there is a neighborship problem. Could be that the internet one port is broken, or the cable is broken, or maybe the router is off, or any reason. And then in this case he will remove the neighborship with router 2 and he will start looking for alternative way to reach the routes where he was getting them from router 2. So what is important for us here, for this neighborship to be between router 1 and router 2, so for the neighborship to be formed, in this case the hello interval and the dead interval should be matched on router 1 and on router 2. For example, if you have on router 2 instead of the dead interval instead of 40 is 50, then in this case you will not have a neighborship between the two routers. So these are the conditions that is needed to be met in order for the two connected routers to become neighbors inside the OSPF. Again, they should be on the same area ID, they should have the same authentication, they should be on the same network, and they should have the same hello interval and the dead interval. There is still one more thing also, which is not appearing here, but it's more advanced topic. Both routers, they should be on the same area type, okay? Like stub area or not so stubby area. That's something we will discuss it later. It's an advanced topic. But for now, let's only consider those are the conditions that we need to have in order for the two routers to form neighborship inside the OSPF. I hope this lecture was informative for you, and I see you in the upcoming lecture.